Hello everyone, welcome to my channel Coding Together. My name is Vikas Ojha. Today we will see another Leetcode problem, that is longest increasing subsequence. It's a medium type question. So we are given with an array of nums and we have to return the longest strictly increasing subsequence. We have already done this question with a recursive approach and we have optimized the brute force method with an memoization approach, that is DP top down. With the DP dynamic programming with a top down approach. Now we will see the tabulation approach will be our bottoms up approach. So let's see how we can what is the idea behind solving this question using tabulation approach. So as you can see, I have already taken the array. Now what we will see, the idea behind solving this problem would be like, we will start from left to right, means from the smaller problems to larger. That is the idea for the bottoms up approach, that we have for the smaller values and we will move to the larger problem. So we will start from the left to right. So if you see that, now we will talk about the LIS, that is longest increasing subsequence at each index or for each element. So when I say longest increasing subsequence for each element, we can assume, or we know that even if we don't include anything apart from its own itself, like if I say that in 1 2 3, if I take 1, the longest increasing subsequence for 1 will be 1, and 2 will be also 1, and 3 will be also 1. So they individually contribute towards the LIS as one length of subsequence. So initially we will also initialize our LIS for all the elements as 1, that we know. Now now let's see the element at the leftmost index, that is 10. Now what we have to see here is the LIS at 0th index, or LIS for the element 10. So what it means is we have to find the longest increasing subsequence ending at 10. So because, as we talked about just now, if we have the single element, then the longest increasing subsequence will be equal to 1, because if I take 10 and the only subsequence I can take is 10, that is of length 1. So the longest subsequence will be 1 of length 10. Now for 9, now we will include 9 in our subsequence, so another will be 10 comma 9. So first we have to see like what all subsequences we can derive from these two elements. So we can say 10 comma 9, 10, 9. So we have to take that subsequence which is longest and which is ending with 9 and strictly increasing. So 3 conditions. So this is not meeting all the 3 conditions. This is also not meeting our 3 conditions. This is ending with 9, but it's not longest. It's not increasing. This is not ending with 9, and this is only increasing. This is ending with 9. This is the only longest we have. So for 9, in 10 and 9 both included, we will have only subsequence ending at 9 will be 1, the longest subsequence. Now for 2, again it's smaller for the previous 2 elements, so again it will be 1. For 5, we can see from 10 to 5, the subsequences we can make is 10, 9, 2, 5. So what will be the longest subsequence ending at 5? It will be 2, 5. That is of length 2. So in other words, as we know that the LIS of 5 or every element is 1, so we'll check behind, means it can come after which element. So we can see that it can come after only 2, and it has already the LIS of 1. So we'll do 1 plus 1 and increment the value of the LIS of 5 to 2, and we can say that ending LIS ending at 5 will be 2 with elements 2 and 5. Similarly for 3, we'll see like after which element 3 can come. So we can see that it will not come after 9, 10 and 9. It can come after only 2. So 2 has the highest the LIS as 1. So we'll do 1 plus 1, that is 1 from the 2 LIS of the 2, and 1 for the 3, that will be 2, and the elements will be 2, 3 in the longest increasing subsequence for ending at 3. Again we'll see for 7. So we have now 10, 9, 2, 5, 3, 7. So the longest increasing subsequence ending at 7 will be 2, 5, 7 and 2, 3, 7. So we can include either this or this. So the longest will be 3, the LIS will be 3 and the elements will be 2, 5, 7. Let's take this one. And for 18, we can see after which we can place this 18. So we can place after this as well, but it's better to put after 7, because after 7 we'll get the longest increasing subsequence. So 2, 5, 8, 17, and the longest is 4. So we will get the maximum LIS out of this. In our case it's 4. So the longest subsequence is 2, 3, 7, 8, 18, or 2, 5, 7, 18. So it will be a n square complexity, because for each element we are iterating again. For example, for 18 we checked from 7 this, which one is the maximum. For 7 also we checked the previous elements. So it's n square, 2 loops. Now we'll see like whether we can do this in a lower complexity, like n log n, whether we can reduce. So yes, we can reduce this in n log n using greedy approach. We can be greedy of finding the position. So how we can this will be the algorithm will work for the binary search. We'll use binary search here instead of just normal search. So let's see how we can proceed. So same array. So what there is another let's see, like suppose we have an array, empty array, that we call dp. So or we can maintain many lists. For example, if we take 10, we will have the first element as 10 in our list, because it's the first element. We'll add it. We'll see 9. So can we put 9 after 10? No, it will not be increasing. So what we can do is this list, this can be our list 1, and this can be our list 2 with 9 in it. And again we'll check 2, whether we can place 2 in list 1 or list 2. No. So we have to create our list 3 with 2 as an element. Now we will check 5. So whether we can place 5 here? No. We can place 5 after in the list 3 after 2. So we'll place here. We'll check 3. So we cannot place 3 in this list. We cannot place list in this list. We can not place in this list after 5. So what we have to do is we have to again take a list 4. That will be like we have to take all the smaller elements as well. from 3. So we will say 2 comma 3, that we will put in list 4. Now we will see 7, so we can, yes, place here after 2 5 7. 18, yes, we can place here, that will be longer. So in this way we can also, you know, do this, but the list, maintaining the list and all will be more complex. So what we can do, a better approach, so here is the trick that we can see is, actually when we saw 10 and we included in our list, and then we saw 9 after 10. So what we will do is we will remove this element from our list and we will add 9. Why? Because removing this element will not matter, and we will only maintain one list, and removing this element does not matter to us, because we don't want first of all the values, the integers of the longest increasing sum, means don't want the values, we only want the length. So also if you'll check that when 10, we had placed initially 10 in our list and then 9 came, then it will, if we replace from 10 to 9, it will increase the possibility of longest subsequence only. It will increase the possibility. Why? Because suppose we had 10, and now the possibility is that we can have a number greater than 10. If we are having if we want the number greater than 10, then suppose 11. So if it is greater than 10, it will automatically be greater than 9, because we are replacing the larger elements with the smaller elements. That's why the possibility of increase the LIS will be increasing if we replace this term. So let's see, if it was 10, then we replaced with 9 at the 0th element, then we saw 2. So again 2 is smaller than 9, so we will replace it, because it will give us the higher possibility of increasing longest increasing subsequence. Now we have 5. So 5, yes, we can place after 2. So yes, so suppose it was, we had not removed 9, 9 with 2, so we could have not placed 5 after 9. So it will give you the more possibility. You can try with some other combinations as well. So now we have placed 5. Now 3 has arrived. So we'll see at which position we have to remove. So we will remove the the next smallest element larger than 3. So the next smallest element, next closest or smallest element larger than 3 is 5. So we'll remove 5 and then we'll place 3. Now we have 7, so we'll place 7 because it's larger than 3. Now we have 18, so it's larger than 7, we will place 18. So the length of this list, the resultant list, will be the actual longest increasing subsequence that we will have. Okay, so this reduced our complexity, time complexity, to n log n, because for every element we are using the binary search to find the element. Now we'll see the code here. It's a simple code that first we are taking the n as a nums length. We are creating our DP array. We can also say it as LIS. The length, all the DP is initialized to 0. Now the initial length is 0. For each element we are doing a binary search, so this will give you the I value, that the position where we have to replace the smaller values that we talked about. So every time we were replacing our target value that was greater than the value that that arrived. So we had 2 and 5, so we found the position. So this position will be given by the binary search. This is a extra overhead that we have to take care of this function, because binary search, arrays.binary search will give you in the negative index, if in the negative index the value where it has to be placed. So suppose this is the value, so binary index will give us -2 instead of 1. So that's to take care that we have done a little if clause, that if I is less than 0, we'll do a minus, we'll revert the sign and we'll get the actual index, and we'll replace the dp at the ith index with that value, and we'll increase our length. So why we are increasing our length? Because we want to do our binary search in the dp array of that length. So suppose initially it was 10, so we want our binary search to perform in this 10 only. Suppose we have in our dp that is 2 and 5, so we want our binary search to perform in 2 and 5 only, because we have only 2 elements. So that's why we are always keeping as 0 and length as our start and end index. So, and finally we'll return the length of the dp that we have, and that will give us the longest increasing subsequence. So let's run this code. Yeah, test cases are passing. So hope you like the video, and for more such videos, please share and subscribe my channel. It will give me motivation to keep making these videos for all of you. So keep supporting, guys. Please share and like. Bye.